KP classes dedicated to excellence.
Hello everyone, welcome back to the second part of this lecture series where we are solving the GATE 2024 question paper. In today's session, our focus would be on part B1, that is the architecture part of GATE 2024. The focus of today's lecture is part B1, that is architecture part. Before I start with this particular session for the solution for the architecture part, let me tell you an important point over here with respect to part B. So part B, where you can make a selection between architecture or planning, as you probably are aware, you will have a total of 16 questions, which will give you a total weightage of 25 marks. From these 16 questions, you will have 25 marks. Now, these 16 questions are further divided into 1 mark questions and also 2 mark questions. And you have multiple choice, multiple select and numerical questions in the 1 mark questions too. And you also have similarly all the 3 types: multiple choice questions, multiple select questions and numerical answer type question. All the 3 are also asked in 1 mark, are also asked in 2 marks, giving a total weightage of 25 marks from 16 questions. That's the structure of part B, which you probably already are aware. If I tell you about one important observation from GATE 2024 paper, in 2023, the last year's question paper of GATE Architecture, GATE 2023, there were no numerical questions asked in the 1 mark. And in part B, that is part B, B1 or B2, architecture part or planning part, there were only 2 numericals out of all these 16 questions. There were 2 NAT questions asked in the year 2023. Now that number has increased to 5 questions in 2024. So there are 5 numerical answer type questions out of 16 in this year's paper 2024. So that's a huge increase in the number of numerical questions. Both again, see, 1 mark question, all there are numericals. NAT type question was also asked in 1 mark. NAT type question was also asked in 2 marks. So in the last year's paper, relatively the numerical answer type questions were less in number, but this year again the number has increased both in the common part, architecture and planning, all the 3 parts. Also the NAT type questions, there is an increase in the number, as you can see, from 2 to 5. That's an increase in the number of numerical questions in 2024 question paper. That aside, now that is nothing as such. The only reason I'm telling you about this point is not because that the number of numerical questions are increasing going down the lane or decreasing down there. That's no such observation is to be made. The only point to be remembered is there is no fixed number of numericals which you will get in the GATE examination. On an average, you can get around 3 numericals plus or minus 2. That is something which you can expect in the part B if I talk about architecture part or planning part. So with that brief introduction with respect to, because many students tend to have a confusion with respect to the type of questions, weightage of questions, so I thought I will clear that in the beginning. So let us begin with our session now, where we will be solving all the 16 questions of the architecture part in this short session. So let us begin firstly by looking into this question number 50. So these are the 1 mark questions first, and then we'll be moving on to the 2 marks questions. Both will also solve the multiple choice, multiple select and numerical type questions. So starting with this first question, this was a 1 mark multiple choice question. Rose window is a characteristic feature of. So I'm sure you all are aware of what rose window is. Rose window is a type of circular window which is typically seen on the entrance. So it is designed with colorful glasses and with tracery patterns, which are generally decorative stonework patterns, which you see on top of the entrance. These circular windows are called as rose windows, which is a characteristic feature of Gothic architecture, Gothic style of church. Gothic architecture is known for its pointed arches, colorful windows, circular windows called as rose windows, pinnacles, spires and towers. These are the features, characteristic features of Gothic architecture, and you'll need to, from the given options, if you look into the options, Great Temple of Amun-Re of Karnak in Egypt, that obviously is not a Gothic temple or the church. Temple of Jupiter in Lebanon, obviously not a Gothic structure. Notre Dame Paris is a prime example of Gothic architecture. So this would be the answer. Humayun's tomb at Nizamuddin, Delhi also does not have a rose window. So the correct answer for this question, which is the only Gothic structure from the given options, that is option C. So if you know, this is how you need to study history. Styles, characteristic features and then examples. That way, whatever type of question is asked, you can easily come up with an answer for that. So that's one question. The next one, This is from the topic of HVAC systems or air conditioning systems. It is based on the concept of refrigeration cycle. So let us look into this question. The schematic diagram of a unitary air conditioner operating in cooling mode is shown in the figure below. Component P marked in the figure represents. They're asking what is the coil in the indoor. So if you know about the refrigeration cooling cycle, so that it is also important to note that the air conditioner here is working on cooling mode, because in cooling mode and in heating mode, the same refrigeration cycle, the indoor and outdoor coils will be exchanged. Let me not confuse you, but if I talk about the basic constituents or basic component, there are four basic components in refrigeration cycle. The working principle. Refrigeration cycle is the working principle of any air conditioner or any cooling cycle, and refrigeration cycle has four main components: a compressor, where the refrigerant passing through the four components. So the four components are connected through copper tubes through which the refrigerant flows. The refrigerant flows through a compressor where the refrigerant is compressed so that its pressure is increased. So this pressurized refrigerant then flows into a coil, which is seen in the outdoor unit of a split air conditioner for that instance. So this coil is referred to as the condensing coil. Condensing coil, as the name suggests, that's where the refrigerant is condensed to the liquid form. So that's the condensing coil. Then the third component, that's an expansion device or an expansion valve. And then comes the indoor coil, which is the evaporator coil, where the evaporation of the refrigerant takes place in the indoor unit of the air conditioner. This is the evaporator coil. So these are the four components of refrigeration cooling cycle, starting with compressor number one, condensing coil, where the refrigerant is condensed to liquid. This pressurized liquid refrigerant passes through the expansion valve, that's the third component, where the pressure is suddenly released, and that's where cooling takes place. The refrigerant cools down, and some part of it also gets converted into vapor. So at this point the refrigerant will be a mixture of liquid and vapor, but in cool temperature, at a lower temperature. This liquid refrigerant then evaporates in the evaporator coil. The evaporation here takes place by absorbing the heat energy from the indoor air, and that's how you get the cool air over here. So at which coil or which component of the refrigeration cycle do you get cool air? Cool air is produced at evaporator coil. At which component does the refrigerant gets cooled down? The refrigerant gets cooled down at the expansion valve due to sudden fall of temperature. So these are the four basic components which you probably have an idea. There was a question in past 2022, I guess, also on the refrigeration cycle, where they asked for the state, the physical condition of the refrigerant flowing through the components. However, to come back to the question where they are asking the cooling coil, or the coil where cooling takes place in the indoor unit, that's what they're asking. It is evaporator coil. That should be the answer from the given options. Evaporator is option B. So that would be the correct answer. The outdoor coil here is condensing coil. All these are for the cooling mode of air conditioner. That's about question number 51. Moving on, so that was a simple, straightforward, direct question on the concept of refrigeration cycle. Moving on to the next one. Titan Integrity Campus in Bengaluru is designed by, so it's architects and the work now. So Titan Integrity Building is very popular. It has been a popular building mainly because it is a commercial. It's an office building, office space. Now this building is considered to be a prime example for sustainable architecture because of its sustainable building practices, with lowering the energy consumption. So it has been rated as a platinum rated green building under LEED certification. It also is a 5-star rated GRIHA 5-star rated green building. So it is a very popular exam. So whenever you get architects in the works, general trend in the gate examination, you do get questions on international architects and also Indian architects, and generally questions are asked from buildings which have been popular due to some aspect in the recent past. Now this building, as I told you, it is popular mainly because of its platinum rated LEED certification and also 5-star rated green building. So Titan Integrity Campus at Bengaluru is designed by Sanjay Mohe from the given options. The correct answer over here would be Sanjay Mohe. Option B would be the correct answer. So that's about this question number 52. Again, a straightforward one. The next one, a very simple question which has been asked with respect to the marking. So this, starting from this question, question number 53, this is a multiple select question. So let's try to look into this question. This is a multiple select question. As I told you in the past session also, in this question paper which has been published on the GATE website, it is not marked, the headings are not written as to what is MSQ, which is MCQ and NAT, but in the actual question paper, in the actual examination, it would be clearly mentioned against each and every question as to which type of question it is. So this is a multiple select question where you'll need to mark the parts over here given in this figure with respect to arch. So before we answer to the multiple select, multiple answers can be correct. Before we start answering the questions, let us try to mark, because you have only 5 parts, let us try to mark the names of these parts. So starting with Q, I'm sure you all know the central washer is referred to as keystone, the central block which basically holds everything together, all the washers together in an arch, that's called as keystone. Then as far as the arch geometry is considered, R over here, that's called as span of the arch, the horizontal clearance, the vertical clearance, which is marked as T, that is called as rise of the arch, rise and span. Then you have keystone. Moving further, the external lining of the arch, which is P, that is called as extrados. The inner lining is referred to as soffit or intrados. Moving on to this point S, which basically is a support structure which is at the bottom after the impost. Basically, you have an impost over here. Below that, this part is called as the abutment. So let us try to select the correct options which have marked these parts correctly. P extrados, correct till there. Q is key, that's also correct. R is span, so option A would be the correct one. Moving on to the next one, Q is marked as key, that's correct. S is marked as abutment, T is marked as rise, so that also is a correct option. The next one, P is abutment, which is not correct, so this is an incorrect option. You need not even check the remaining points. Q is key, that's correct till there. S is span, S is not span obviously, S is abutment, so that's also an incorrect option. So the correct options in this multiple select type question for 1 mark, the correct answers will be A and B. So that's the correct answer for question number 53. Moving on to the next 54th question. It again is based on the topic of history of architecture. Which of the following buildings has or have pendentives as structural element? Which of the following options have pendentive as a structural element? 4 options are given. It's a multiple select type question again. Now what is a pendentive? I'm sure you all are aware pendentives are concave triangular sections which basically support a dome and transfer the load of a circular plan dome onto a square plan. Because dome has a circular plan, in order to transfer the load of the dome onto 4 points, you use these triangular sections. So these triangular sections or circular triangular sections, you can say concave triangular sections, which transfer the load of a dome onto 4 points. So you have 4 pendentives, generally 4 or 8 pendentives are used to transfer the load of a dome onto a square base, where the load will be transferred onto these 4 columns or 8 columns placed at the bottom. This particular composition of supporting a dome with a structural element, which I have shaded over here, so these triangular sections are called as pendentives. Use of pendentive is something which you see in church architecture generally. A similar element which you generally see in Islamic architecture is referred to as a squinch. So from the given options, you can remember that pendentives generally, it's not a hard and fast rule. There are Islamic structures, Islamic architecture structures too, where pendentives have been used. For example, Gol Gumbad has interlocking pendentive system to support. There are always exceptions, but in general, pendentives are found in church architecture, whereas squinches are found in Islamic architecture to meet the same structural purpose of supporting dome over a square plan. If you look into the given option, St. Mark's Basilica at Venice, Italy, that is an example of a church which has use of pendentives Westminster Cathedral in London is not something which is a prime example where you have domes and pendentive system. Dilwara Jain temple does have a dome but does not use pendentive structure to support the dome. Haya Areen Museum and Concert Hall at Istanbul, which is a prime example of Byzantine style of church construction. That again is an pendentive and itself is a prime example for Byzantine. So it's an important element of Byzantine style of church architecture. That's where it was originally introduced. Later on, its application was seen in later eras, including in Renaissance structures and churches too. So from the given options, option A and D are the relevant correct options, where use of pendentive was seen to support the dome structure. So that's question number 54. Moving on to the next one, question number 55. PTFE, polytetrafluoroethylene, PTFE, coated fiberglass has been used as a roofing membrane in Dash. So some stadiums, cricket stadiums particularly, have been given Jawaharlal Nehru Stadium in New Delhi, Eden Garden at Kolkata, Melbourne Cricket Stadium in Melbourne, and Beijing National Stadium, Beijing. These are the options given. Now this question was given as a marks to all question in the preliminary answer key itself. So anyone who has attempted the architecture part will be given marks for this particular question. The main reason is fiberglass is something which does not come under membrane, roofing membranes. So tensile structures are generally referred to as roofing membrane structures. Now fiberglass in itself probably would not be categorized under that particular say part. However, PTFE coated fiberglass is something which has been used in Eden Garden Stadium at Kolkata, also Jawaharlal Nehru Stadium, but then there's no point in discussing it further because it's a question of marks to all. So it was expected, so it is something where important buildings and the prominent construction material was asked, but then it's a marks to all question. That's question number 55. So let me skip through that. That's a 1 mark question, however. So anyone who has attempted the architecture part will right away get 1 mark, even though if you have attempted this question or not. That's a marks to all question. Next one, question number 56, the last 1 mark question before we move on to the 2 marks questions. So this question is based on elevator and the calculation of say time probably. Let us go through this question. Let us first understand the given information and then we'll try to solve it. So starting with the given information, for a non-stop express elevator directly connects the observatory level at 80th floor of a tower with the podium at 2nd floor level. So the first point given over here, there is a observatory level at the 80th floor and the podium level where the lift is going to start, that is given as the 2nd floor. And the floor to floor height for every level, so the uniform floor to floor height is given as 4 meter. So what will be the total height over here? The total height is going to be 78 into 4 because there will be 78 intermediate levels between the 2nd and the 80th floor. So the total height 78 into 4, that will come out to be 312. 312 meter is the total height which the elevator has to move. That's the first two. Those are the first 2 points given. Moving on to the next point. The tower has a the elevator attains a maximum speed of 8 meter per second. So the maximum speed that's given as 8 meter per second which it can attain, assuming 2 meter per second square as the net vertical acceleration and net deceleration incorporating gravity. So whenever the lift is accelerating or whenever the elevator or the lift is decelerating, the acceleration, rate of acceleration or deceleration, both net acceleration, let me acceleration, the net acceleration or the net deceleration also, because before stopping the lift has to decelerate as well. So acceleration or deceleration, both in both the cases, so that value is given to be 2 meter per second square in case of deceleration, including gravity's effect. In both the cases actually, including the effect of gravity, the net effect is given as 2 meter per second square. If the elevator starts from state of rest, so the initial velocity it is starting from rest over here, and finally also it is coming to rest over here. The time taken for the lift to reach the observatory, so basically the way the lift is moving is, it is starting from rest, It is accelerating at 2 meter per second square, reaching a maximum. It is not accelerating indefinitely. It is accelerating till it reaches a maximum velocity of 8 meter per second, and it is constantly moving at that 8 meter per second of speed, and then it starts to decelerate so that it has to come to rest at the 80th floor, and that rate of deceleration also is given. So basically the movement of the lift is in this way: the velocity starts from 0, it is slowly increasing and reaching till 8. It is constantly moving at a speed of 8 for some distance, and then it is decelerating and reaching back to a velocity of 0 finally. That's the given movement. Now what is the total time taken for this lift? That's what they're asking. You can use simple equations of motion like which you have probably studied in your school days in your physics. Let us try to apply that. First we will look into the time taken for the accelerating part, the time taken for the steady state or the steady flow part. So you'll need to divide this movement into three parts. So initially there is a portion where the lift is going to accelerate, there is a portion where the elevator is having a constant speed, and finally there is a portion where the lift is going to decelerate as well. So there is an acceleration part, steady state, steady flow part of 8 meter per second velocity, then deceleration part. So first let us start with the acceleration part. Let me try to solve it over here. So acceleration part, if you see starting so if you apply the equations of motion, let me write first part, the accelerating portion, the part where the lift is going to accelerate. The initial velocity u is 0 meter per second. The final velocity, it is reaching the maximum velocity, that is 8 meter per second. Acceleration rate, the net acceleration rate, that's given as 2 meter per second square. So you can apply the equations of motion. What do you need to know? You need to know how much distance did it cover from this point to this point in this process of reaching from 0 to 8 meter per second. How much distance has the lift moved, and how much time it has taken. So firstly let me apply this equation: v square minus u square is equal to 2as. That's an equation of motion which you have. The final velocity, v square minus u square is equal to 2 into a into s, where s is the distance traveled. So if I apply that equation, v here is 8 minus u square, v square minus u square, original velocity, initial velocity is 0. 8 square minus 0 square is equal to 2 into, the rate of acceleration also is 2 into s. So what is the distance it has covered in the process of acceleration? It is 8 square, that is 64 upon 4, which will come out to be 16 meter. So let me write it over here in the first part, that is the accelerating part. We have solved for the accelerating part, and we have observed that the distance traveled, let me mark it as S1, that is 16 meters. And what is the time it has taken in this particular part? For that you will need to apply a second equation of motion. Say probably v is equal to u plus at, final velocity is equal to u plus acceleration into time taken, v is equal to u plus at. If I apply this, you can also apply the third equation of motion. Either way you will get the same answer. So v final velocity is 8 is equal to u is 0 plus the rate of acceleration is 2, and the time taken you need to find out that. So the time taken is going to be 8 upon 2, that is 4 seconds. So how much is the time? The distance covered in the accelerating part is 16 meters. The time taken is 4 seconds. So the time, let me write the time taken T1 as 4 seconds. That's about the accelerating part. If you look into the second portion, there is a constant speed part. So for that constant speed part, you will be able to know how much is that constant speed distance. That you will come to know once you solve the decelerating part only. So let us do the same calculation what we have done over here, just like for acceleration. Let us try to do the deceleration part. Let us try to solve and get the values of both the distance and also the time. So I'm not erasing the equations because we'll be using the same equations over here again. Okay, so if I so for the decelerating part, let me mark it as 3. That is the deceleration part of the movement of the lift. The deceleration part of the lift, initial velocity, it will be 8. Now these values also will be changing. The initial velocity over here, that will be 8 meter per second. Before decelerating, it will be at its peak velocity, and it will decelerate and reach a final velocity of 0 meter per second, and the rate of deceleration is given as 2 meter per second square. So if I'm writing a, because it's a decelerating speed, I'll write it as -2. So the acceleration rate over here will be -2 meter per second because it's a decelerating rate. So let us apply the same equilibrium equations. Let us apply the same motion equations of motion again. V square minus u square is equal to 2 into a into s. V square is 0 square minus u square is 8 square is equal to 2 into a is -2 into s. So if you simplify this minus and minus gets cancelled on both the sides. You will get s is equal to, again the same thing, 8 square divide by 4. So that will also come out to be 16 meters. So let me write over here the third point. Second part we will solve it. So the decelerating part of the movement of the lift, if you see the distance covered, I'll write it as S3. That distance also is coming out to be 16 meters. What is the time taken? Let us see. The final velocity is 0, initial velocity is 8, plus the acceleration rate is -2 into time taken is t. So if you simplify this implies the time taken t is equal to -8 divided by -2, which will again come out to be 4 seconds itself. So it is the time of the third part of the third leg of the deceleration part of the third leg of the movement, that also is 4 seconds. The initial time is 4 seconds. Final accelerating, the process of accelerating from 0 to 8, it is taking 4 seconds. In the process of decelerating from 8 to 0 again back to 0 at the point of rest, that is also taking 4 seconds. Now what is the constant speed part? For that you will need to see what is the distance of the constant speed. We already saw what is the total distance. We just saw the total distance that the elevator has to move, that is 312 meters from the second to the 8th floor. So what will be the constant speed part? That second leg of the distance, the total distance is 312, of which 16 meter is the accelerating part and 16 meter is the decelerating part. 16 and 16 is 32. If you subtract 32 from 312, you should be getting 280 meters. 280 meters is the distance of the constant speed part. Now how much time will it take to cover 280 meters at a constant speed? What is that constant speed? The maximum speed, the constant speed velocity over here, that is 8 meters per second. At a speed of 8 meters per second, how much time will it take to cover 280 meters? So simple formula, the time taken will be distance divided by the speed, because speed is nothing, velocity, speed is equal to distance traveled per unit time. So what will be the time taken? It will be distance upon speed. So distance, the time taken for the second leg of the movement, T2, let me write, that will be the distance traveled 280 divided by the speed of it, that is 8. So if you simplify this, 280 upon 8, how much are you getting that as? 35 it is, right? So this is taking us 35 seconds. So we have solved all the 3 legs of the movement of the elevator. Initially it is accelerating for 4 seconds, moving at a constant speed for 35 seconds, and is decelerating again for 4 seconds. What is the total time for the lift's movement? It is 4 plus 35 plus 4. That will come out to be 8 plus 35, that is 43 seconds. So the total time taken, so the answer for this question, what is the total time taken, that they're not asking us what is the part of each of the movements, they're just asking us the total. So it is 4 plus 35 plus 4, that's the final answer, which will be 43 seconds. They're asking us the answer in integer, rounded off to 1 decimal place. It is coming out to be 43. The official answer keys range, I think, also is similar. It is given as 42 to 44, which is exactly in the center of the range. So it is perfectly correct to solve it this way. So 43 would be the answer for this question. So you just need to, it's not difficult, it's based on your +1 +2 level of probably physics which you have studied in your school days, but then you'll need to understand which aspect or which part to apply, and more importantly understanding the nature of movement. That is very important. Ability to understand that the movement is having an accelerating part, a constant speed part and a decelerating part, that's the key in solving this question. However, it is a bit lengthy, but then it was asked just for 1 mark. A small question. So it was not something difficult, but again, it is a bit lengthy, you can say. 43 is the correct answer for this question. Let us now move on to the 2 marks. So that's about the 1 mark part. Let us now move on to the 2 mark questions, starting with the new theoretical questions first again. Match the elements in group 1 with the corresponding religious buildings in group 2. So which of these buildings have bell capital, which of it has mihrab? Mihrab, I'm sure you all know, it is seen in mosque. Gopuram, I'm 100% sure that you know that it is a part of Hindu temple. Pediment is a part of Greek temples. What is pediment in Greek temple architecture? So in a typical Greek temple, also in Roman temple, in the classical architecture, you have temple facade where you have columns, the classical order columns of Doric, Ionic, Corinthian, Tuscan or composite order based on which style it is, Greek and Roman both. It has in Greek temples typically you have a plinth which is called as crepidoma, which includes stylobate and stereobate. Then you have entablature on top of the columns, which includes the frieze, the cornice, and also the say the architrave. All these together is called as entablature. Then you have a triangular part on top of it. That triangular part of a Greek temple is called as the pediment. So that's what pediment in history of architecture is. So pediment is a part of the Greek temple, so it will be 3 for this. Bell capital from the given options. Bell capital is something which you see in Egyptian temples, Egyptian temple column capitals. There are various designs to it, including lotus flower capital, lotus bud capital. You also have papyrus capital. Similarly, you also have bell capital as well in Egyptian temple. So 5, 1, 2, 3 would be the appropriate answer over here. Option A would be the correct answer for this question. That's question number 57, which was asked for 2 marks in the GATE examination. Moving on to the next one, 58 question. This again is on architects and their works, probably. Match the museums with their architects direct. Even in the good thing of multiple the matching questions, even if you don't know all the answers, you can try to answer it by from the part which you know probably. I'm sure Gandhi Memorial Museum is something which is very popular and everyone knows that it is an example of the works of Charles Correa. So you can try to see which option is having R1. Okay, that there are 3 options, then you need to look into the other questions as well, other part as well, because for R1 you have 3 options over there. Bihar Museum at Patna, if you are aware, it was designed by Fumihiko Maki, Japanese architect. Bihar Museum at Patna. So for Q it is 5. So 5 and 1 probably you have it only in one option. That will be the correct answer, option D. You can also, if you know other options, you can also answer from it. Indira Gandhi Rashtriya Manav Sangrahalaya at Bhopal, it was designed by Ram Sharma. And Museum of Art and Photography at Bangalore was designed by Soumitra Ghosh and Nisha Matthew. So option 4 for it. 2514 is the correct answer. Option D, as I told you, would be the appropriate answer for this question number 58, which is based on architects and their works. Particularly, Indian museums have been asked in this question. Moving on. This is a question from building materials where they have given pictures. There are some special, these are not brick cuts, but these are brick shapes, specially shaped bricks and the corresponding nomenclature they are asking. Let us try to answer the question from what you know probably. So the first one, that's a brick where 2 of its corners are chamfered off. That is referred to as a double cant brick. So it is 4 over here. Q, that's referred that a brick which has an angular tip on one side, that's referred to as a squint brick. If you know from building construction, there are squint joints and squint junctions as well. So what are squint corners of a room? If you're having a room which is having acute or obtuse angles, those are referred to as squint junctions, right? So squint brick is something which has a tip which is forming an angle on one side. So R and S over here, these are bricks which are generally used at the plinth level, generally in buildings. If I say at the plinth level of the building, these bricks are used which are chamfered, or you have this tip which is inclined. Such bricks are used at the plinth level. So these are plinth header and plinth stretcher. You can clearly see which is header and which is stretcher. This is plinth stretcher because the stretcher part of it has been splayed off. So this is plinth stretcher, so it will be 5. This is plinth header because the header part has been smoothened away or has been inclined cut. You see it on the header part, so it will be plinth header. So 4-3, it is generally used. Why is it called as plinth header and plinth stretcher? Like I told you, it is generally used at the plinth level of the building to create a angular base or a finish. Again, there are other applications. It is also used at sill level sometimes to give that weathered surface at the sill level of a window as well. So 4-3-5-1 would be the correct answer. Option A is the given correct option for this question. 4-3-5-1. So that's again a straightforward question of identifying the diagrams of building materials, that is brick. 59th question it was. Now moving to the multiple select questions. The multiple choice question of the 2 marks part is done. Let us now move on to the multiple select questions over here. So starting with the first one, so question number 60 it is, which of the following statements are correct? Some measurement units from lighting point of view probably are given, lighting and sound both, and energy performance. Let us see. The first one, unit of light power density is watt per square meter. Second option, unit for light power density is candela per square meter, CD per meter square. So what is light power density? Light power density is a metric which is used for energy efficiency of lighting fixtures in space. So if I'm having lighting fixtures in a room, to understand if they're energy efficient or not, to understand the level of scope I have for improvement of the energy efficiency of lighting fixtures, we measure light power density, which is nothing but the total power of all the lighting fixtures, which is measured in watts, upon the floor area which it is illuminating. So light power density is measured in watt per square meter. Option A will be a correct answer, and right away, because option A is correct, B you can eliminate it directly. B will be incorrect. The next one, unit of sound power is watts. Obviously sound power is measured in watts, so you know sound power, or you can, if you know sound power level SWL, that is measured in decibels. In measuring sound power level, we use sound power, and sound power is measured in watts. Sound power level is measured in decibels. The formula for sound power level is 10 log W upon W reference. 10 log power of the source divided by the reference power, which is taken generally as 10 to the power minus 12 watt per square meter. So sound power is measured in watts. That's a correct statement. Sound intensity is measured in watt per square meter, but sound power is measured as power per unit. Sound power is measured in watts. Intensity is power per unit area, that's measured in watt per square meter. The next point, last point, energy performance index. Energy performance index is an important metric in the energy conservation building code for the assessing the energy efficiency of building systems. So energy performance index is calculated as the total units of power consumption per unit area annually, yearly energy consumption per unit area. So if I have a building, throughout the year, how many units of electricity is it consuming, expressed as a measure of unit built up area for 1 square meter area, including the lighting fixtures, the cooling load and everything together. That's called as energy performance index. It is measured in units per square meter per year. Unit of electricity consumption is kilowatt hours. So D also is a correct option. So the correct options over here are A, C and D. That was a 2 marks multiple select question from the question number 60 from the GATE 2024 question paper. The next question. The next one, again it is a multiple select question, which is question number 61. Let us try to answer this one. Which of the following statements are correct? Again it is based on, so if you look into the options, it is various terms used in the context of vernacular architecture. That's the area of this question. The first option, Katkuni construction comprises of layers of stone and timber. Katkuni is a type of vernacular construction used typically in the Himachal Pradesh region in the northern part of India, where stone and timber based construction are used. So that is correct. So it is a construction technique where stone masonry is integrated along with timber based members. It is something which is popular in Himachal Pradesh. So Katkuni is the correct answer. It comprises of layers of stone and timber integrated together. Next one, Naluketu houses have a courtyard. Absolutely a correct statement. Naluketu is a type of architecture you see typically in Kerala. It's referred to as Nalu in Kerala in the language over there. That is 4. So Naluketu is a type of layout in Kerala, traditional architecture of Kerala, where you have 4 halls with a central courtyard connecting them. It is generally used for larger families with 4 halls connected with a central courtyard. So Naluketu houses have a courtyard, which is an important unifying feature in that architecture. So that's correct. ICRA is a two-storied house with stone masonry and a flat roof. ICRA is a type of vernacular architecture which is predominantly seen in the Sikkim region of India, where bamboo-based construction is used, and typically sloping roofs are seen, and ICRA houses are generally single-storied houses. They are proven to be very much efficient in the earthquake resistance construction of that particular region. So two-storied houses with flat roof is not correct. It is a single-storied house with an inclined or pitched roof. So that's an incorrect statement. The last statement, Bunga has a circular plan. Bunga is a type of construction vernacular architecture seen in the Kutch region of Gujarat, where you have thatch-based roof, mud walls of circular shape. The circular shape is mainly a climate responsive feature which has been efficient in blocking the winds, the storm, the winds, say sandy winds of that particular region, and also it is known for its earthquake resistant features. So A, B and D are the correct answers or correct options in this question. That is question number 61. Moving on to the next question, number 62. Now moving on to the numerical part, the last four questions are all 2 marks numerical questions. Let us try to solve them one by one. The first question, this is based on structures. So there was a structures based question in the common part as well, as you know. This is also a structures based question which is asked in the architecture part again. So let us try to solve this. A 5-meter long aluminum tie rod of cross section. So the length is given as 5 meter. The cross-sectional dimensions are given as 0.2 meter by 0.04 meter. Is subjected to a tensile force by its self-weight. So what is the self-weight it is given? The self-weight is given to be 21.2 kg per meter. So the intensity of the weight is given, basically per unit length, what is the weight of it? 21.2 kg per meter, that's the weight of it. Considering an acceleration due to gravity of 10 meter per second square. So from acceleration due to gravity and weight, you can find out the force in the member. What is force in the member? Force is nothing but the mass multiplied by the acceleration due to gravity. That will give you the kg force of it. So you'll need to, again, but this is per unit length for 5 meters. So what will be the force over here? 21.2 kg is per meter. So multiply it with 5 because the total length is 5 meter. The total force will be 21.2 into 5 into acceleration due to gravity, that is 10. So if you multiply this, you will get your answer in kg meter per second square. So this will be in kg meter per second square, because this meter and this meter gets cancelled when you multiply it with 5. Kg meter per second square is nothing but Newton. So the measurement unit, SI unit for measurement of force, that is Newton, that will be 21.2 into 5 into 10. That's the force in the member. So that we have calculated from the second statement. Moving further, if the tensile Young's modulus of aluminum is 70,000 megapascals. So the Young's modulus of elasticity, let me write it as E, that is given to be 70,000 megapascal. Megapascal is nothing but Newton per mm square. So let me write it as 70,000 Newton per mm square. That's the modulus of Young's modulus of elasticity. The maximum tensile strain in the rod is dash into 10 to the power of -6. So what is Young's modulus of elasticity? Stress upon strain. So stress upon strain is given to be 70,000 megapascals or Newton per mm square. They are asking us the strain value. So strain is equal to the stress value divided by 70,000. You just need to take care that the measurement unit is in Newton per mm square. So what is stress now? Stress divided by 70,000. What is stress? Force per unit area is called as stress. So force we have already calculated, 21.2 into 5 into 10 divided by the area, but area you will need to take it in millimeters because we want it in mm square. So if I write this the cross sectional dimensions into millimeter, this will come out to be 200 millimeter by 40 millimeter. Into 1000 if I do, I'll get 200 into 40 as the cross sectional dimensions. So stress is nothing but force per unit area. So the strain value finally will be force, that is 21.2 into 5 into 10, that is force per unit area. The area is 200 into 40 and there is already a value of 70,000 in the denominator. So it will be unitless. Strain is a unitless quantity. You just need to take care that the numerator and denominator are in same units of megapascal, are in same units of Newton per mm square. That I have ensured. So you can simplify this and you'll get your answer. You can use your calculators for that purpose. So let us say 21.2 into 5 into 10 divided by 200 into 40 into 70,000. So that's coming out to be 1.8928 or 1. Let me round off to 2 decimal places. They want us to round off to 2 decimal places. I'll round off to 2 decimal places. I'm getting it as 1.89 into 10 to the power of minus 6. That's the value of the strain I'm getting. So in the given, they're asking us the answer dash into 10 power minus 6. 10 power minus 6 is already mentioned. So the answer from this part will be 1.89 only. So the answer for this question number 62, you can check the official answer key for the range which they have given, but I'm sure it will be within the range of the official answer key. So the answer which I'm getting for this question, it is 1.89 into 10 to the power minus 6. So that should be in the range of the answer key. You can check the official answer key's range for the acceptable range as per the question paper. That's question number 62. Based on stress, strain, and the Hooke's law, basically, stress is proportional to strain, and a definition of Young's modulus of elasticity. That's based on that concept. The next question, question number 63, again a 2 marks question from estimation part. Estimation actually, as per the official syllabus, it is part of the common part, but question has been asked in the architecture. As you know, the boundaries are not very rigid in the examination. Let us try to solve this question. The following figure shows the excavation plan of two-room structure where the trench has a uniform width of 1.1 meter. If the cumulative centerline length of the trench is 41.1 meter and the required depth of the concrete to be poured is 0.3 meter, the volume of concrete in foundation in cubic meter will be. So they are asking us the volume of the concrete in the foundation. The depth is 0.3, centerline length is directly given, width of the excavation is given. You can apply, so how do you find out the volume of the trench? The area of the footprint of the trench divided by the depth, multiplied by the depth of it. Depth is 0.3. So to find out this overall area of the shaded portion, you need to find the area of the excavation footprint. So in centerline method, if you just have a single, say, a brick wall or a excavation trench with a single room, it will be direct and straightforward. You can just take the total length of the center line, multiply it with the width of it. That's the direct straightforward method. So length of the center line multiplied by the uniform width, that will give you the area of this footprint. But when you're having intersections, there will be some deductions which you'll need to do. So if you look into this given diagram clearly, if you are able to divide it into two parts, let us say I will divide it into two rooms or two parts. This part of the shaded portion, so this part, you can directly use centerline method and find out this overall area. But when you are applying the centerline method for this remaining portion, you should not take out this part of the centerline, this portion. You will have to deduct this part, otherwise that portion will be counted twice. I'm sure you are able to understand. So this portion has to be eliminated in the center line for the calculation of the footprint area for this remaining part. So what is the deduction for this? Whenever you're having intersections, remember, you will need to deduct half of the width of the wall or half of the width of the footprint at every intersection. That has to be deducted. So this part and this part. So what will be the effective length of the center line for our calculation in this question? So the effective center line for excavation for the calculation part, that will be the total length of the center line, which is given as 41.1 probably. Excuse me. 41.1 minus deduction. The deduction part, I told you, it is half of the center line, half of the thickness over here, half of the thickness over here. Two times you need to deduct. So total you will need to deduct 1.1. Half of 1.1 once, half of 1.1 again. So you need to deduct 1.1 together. That will give you 40 meters of center line length for the overall excavation. Now, what will be the area? The area will be 40 multiplied by 1.1. the length of the effective length of the center line multiplied by the uniform thickness. So if you don't deduct this 1.1, the overlapping part, that will be counted twice. The shaded part which I have shaded over here, that will be counted twice. That you should not, you should ensure that it is not counted twice. So 40 into 1.1, that will be the area. What will be the volume of concrete in the foundation? The area, that is 40 into 1.1 multiplied by the depth of it, that is 0.3. You can use your calculators to simplify it further. The answer should come out to be 40 into 1.1 into 0.3, which is coming out to be 13.2. So that exact value 13.2 without any range, I think, because they are asking us to round off to 2 decimal places. It is rounded off to 1 decimal place itself. The answer is 13.20. So 13.2 will be given the marks for this particular question. 13.2 is the answer for this question. So make sure whenever you're having intersections, whenever you're having interior walls, you should ensure that you are properly deducting the overlapping area. Otherwise, you will make a mistake over there. That's question number 63. Moving on to the next question. This is based on acoustics. Let us look into this question number 64. The decay of sound in an enclosed lecture hall of volume of 3500 cubic meter. Volume is given as 3500 cubic meter. Is shown in the figure below. The decay of the sound level is given in this diagram. The sound source is switched off at point P. So original level, if you look into this question, what is the original sound level when the sound source is working? It is 110 decibels. Once it is switched off, it is decaying along this path. Using the reverberation time obtained from the figure, so RT60 obtained from the figure, calculate using this. They're asking us what is the sound absorption. So RT, the reverberation time, they're asking us to take from the diagram. What is the definition of reverberation time? RT60. Reverberation time is defined as, RT60 is defined as the time taken for a sound to decay by 60 decibel from its original level after the source has been stopped. After the source has stopped, it should fall. How much time is it taking for it to fall by 60 decibel? So if the original level is 110, if it is falling by 60 decibel, where will it reach? 60 decibel, if it is falling, it will reach to 50 decibels. So what is the time for 50 decibel? The time for the point where they are switching it off, that is 0.4. The time for it at the point of say 50 decibel after decaying by 60 decibel, that is 1.6. So the reverberation time is this particular time gap. The reverberation time is 1.6 minus 0.4. 0.4 is where they are switching off the source. 1.6 is the time at which it is reaching to 50 decibel, that is after falling by 60 decibel. That's the definition of RT60 or reverberation time using Seben's equation. That will be 1.2 seconds. If I apply the Seben's equation now, RT60 is given by 0.16 into volume upon total sound absorption. So what is the total sound absorption? 0.16 into volume is given as 3500. Divide A goes to the other side, you'll get RT60 over here. Divide by RT60, that is 1.2. You can simplify this and you should get your answer. You can use your calculators to do this calculation part. So it is 0.16 into 3500, that's 560. Divide by 1.2, 466.67 is the answer. The answer is 466.67 meter square Sabin, or simply Sabin is the measurement unit for sound absorption. The answer is 466.67. They want us to round off to the closest integer in Sabins. The answer will be 467. If I round off to the closest integer, 467 is the answer. To be specific, it is 466.67. That's this question number 64. That brings us to the last question for this session, which is based on the energy consumption, I think. Let us look into this question. A 2-ton refrigerator, a 2-ton of refrigeration, TR is ton of refrigeration. A 2 TR window air conditioner of energy efficiency ratio is given as 3.1. The cooling load is given as 2 ton of refrigeration. It is catering to the room of a volume of 40 cubic meter. Volume of the room is given as 40 cubic meter. The air conditioner is operational for 600 hours. The time of operation is given as 600 hours. during summer on cooling mode, the compressor is also operational for the complete duration. The compressor is working continuously, they are saying without break, which is a hypothetical situation. Generally air conditioners, they work in cycles. The compressor works in cycles. Whenever the compressor is working, that's when the electricity is consumed. But they are asking us to assume for all the 600 hours compressor is also working. The total energy consumed of consumption of the air conditioner during the above mentioned period in kilowatt hour is dash. They're asking us what is the total units of electricity consumption. How do you measure the power consumption or electricity consumption? So you might have heard what is the unit of electricity. What we generally use the term unit for that. Generally, we use the term unit. Units of electricity consumption is nothing but kilowatt hour. The power, rated power in kilowatts multiplied by the time. So let us try to solve this question. You need to first convert this ton of refrigeration into watts. How do you convert cooling load of ton of refrigeration into watts? The conversion factor is 1 ton of refrigeration is taken to be approximately 3.5 kilowatts. Approximately, to be specific, I think it is 3.516 or 3.517, probably something like 3.5168 or something like that. So approximate, or to be exact, the value is 3.51, probably 6 after that, or you can say 3.5 kilowatts approximately. That's the conversion which you have to remember, which I'm sure all those who have studied HVAC or air conditioning systems, you know that the conversion for 1 ton of refrigeration is 3.5 kilowatts or 3500 watts approximately, it is that. The exact value is 3.5168 in watts, or sorry, in kilowatts, right? This is in kilowatts. So what will be the cooling load? It will be 3.5 into 2 in kilowatts, that will be 7 kilowatts. Approximately 7 kilowatts, to be specific it will be 7.2 or something. So you can always remember the approximate value 3.5. That's what generally in a lot of past gate questions too, multiple times whenever question has been asked on ton of refrigeration of cooling load of air conditioner, they have given this conversion factor. So here the only aspect is they have not given that conversion factor. You have to remember it. 1 ton of refrigeration is 3.5 kilowatts. So the cooling load is coming out to be 7 kilowatts. Now if the cooling load is 7 kilowatts, what is the power consumption? That you will know from energy efficiency ratio. What is energy efficiency ratio? Energy efficiency ratio is defined as the ratio between the cooling load. It is cooling load in watts divided, the actual definition of energy efficiency ratio, it is cooling load in BTU per hour, British thermal units per hour, upon power consumption in watts. However, in India, we use a watt upon watt ratio for energy efficiency ratio, or for Indian seasonal energy efficiency ratio, we use that watt upon watt. So cooling load in watts divided by power consumption in watts, watts or kilowatts or whatever it is. So this implies the power consumption is coming out to be cooling load, that is 7 kilowatts, divided by the energy efficiency ratio, that is 3.1. Basically power consumption goes to the other side, cool EER, energy efficiency ratio, comes to the denominator. So 7 upon 3.1, what is the power consumption in kilowatts coming out to be? It is coming out to be 2.258. 2.258 in kilowatts. That's the power consumption. What is the total power consumed in, or energy consumed in kilowatt hours? Electricity consumed. Electricity consumption will be the rated power of the appliance in watts, that is basically power multiplied by the time of usage, kilowatt into hour. The power has to be taken in kilowatts, that is 2.258, multiplied by the time is taken in hours, that will be 600. So the answer in kilowatt hours will come out to be 2.258 multiplied by 600, which is coming out to be 1354.8. They're asking us to round off to the closest integer, so I can round it off to 1355. So 1354.8, if I round off to the closest integer, the answer will be 1355 kilowatt hour. That's the answer. So you should be aware of what is the definition of energy efficiency ratio, what is the conversion for ton of refrigeration to kilowatts, and how do you calculate the electricity consumption? It is the power multiplied by the time. For that power, we calculate it from the energy efficiency ratio. So that's a question excuse me, on the air conditioning systems. Again, that's the last question for this particular session. So we will have another session for the general aptitude, and we'll have a separate session for the planning part as well. Keep following our YouTube channel. You can subscribe to this YouTube channel, share this with all your friends, whoever has attempted GATE 2024 or is planning to prepare for GATE 2025. I hope this was helpful and useful for you. Stay connected with KP GATE classes on all the social media handles to be updated in your GATE preparation and other government job preparation in the field of architecture and planning. Thank you, everyone.